Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is detection in high-rise buildings. High-rise buildings are structures such as residences, offices, hotels, shopping malls, and mixed-use areas where a large number of people are present at the same time. In the event of a fire in these buildings, evacuation and intervention become difficult, which can quickly lead to serious loss of life and property. Therefore, fire safety in high-rise buildings must be addressed with a much more comprehensive and integrated approach compared to traditional building solutions. Fire detection systems form the foundation of fire safety in high-rise buildings. The most important function of these systems is to detect a fire at an early stage, warn building occupants in a timely manner, and initiate the evacuation process safely. However, in high-rise buildings, fire detection alone is not sufficient. It is vital that detection systems operate in coordination with other systems such as smoke control, evacuation, public address, elevator control, and building automation systems. From a fire safety point of view, correctly classifying building types is very important because it directly affects which system needs to be used. That's why before talking about fire detection and perimeter systems in high-rise buildings, we first need to be clear about what we actually mean by a high-rise building. In international sources such as CTBUH, Council on Tall Buildings and Urban Habitats, ISO, and general fire safety literature, buildings that are around 23 meters or taller are usually considered high-rise buildings. The main reason is that beyond this height, it becomes difficult for firefighters to effectively respond from the outside. Buildings over 100 meters are commonly referred to as skyscrapers. Simply put, a high-rise building is one where outside intervention is limited, which makes internal fire safety systems especially important. IBC, which is International Building Code, is a widely used building code that sets basic rules for building safety, fire protection, and life safety. It is mainly applied in the United States, but also used in other countries either directly or with local modifications, and it serves as a reference during design, permitting, and inspection processes. According to the International Building Code, automatic fire alarm systems are required based on the building's occupancy type and height, ensuring early detection and timely warning. For high-rise buildings, this requirement goes further by mandating not only automatic fire alarms, but also emergency voice and alarm communication systems, which are essential for safe and controlled evacuation. In addition, fire alarm systems must be fully integrated with other life safety systems, such as elevator recall and smoke control, so that critical emergency functions are activated automatically during a fire event. To support fire department operations, high-rise buildings are also required to include a dedicated fire command center where all fire protection and alarm systems can be monitored and controlled. Fire alarm call points are typically located on escape routes, near stairwell doors, and corridor intersections. The purpose is to ensure that a person who notices a fire can easily reach the button while proceeding towards the exit of the building. This image shows how manual call points should be placed in a building according to IBC and NFPA 72, which is the National Fire Alarm Signaling Code published by the National Fire Protection Association in every 3 years. And as you can see, the call points are located next to the exit and exit access doors, and they are clearly visible along evacuation routes. One key rule highlighted here is the maximum walking distance. A person should not have to walk more than 60 meters or 200 feet to reach a manual call point. And the image also shows the correct mounting height, which is between 1.07 and 1.22 meters from the floor. Overall, the diagram helps explain how proper placement ensures quick access and faster response during an emergency. So, one of the greatest dangers of fire in high-rise buildings is the rapid spread of smoke between floors. Stairwells, elevator shafts, and utility ducts can cause smoke to be carried to upper floors through a chimney effect. This poses a serious risk of loss of life, even on floors much higher than where the fire originated. Therefore, fire detection systems must work in integration with smoke extraction and pressurization systems. When a fire is detected, smoke extraction systems on the relevant floors are activated, and while escape routes and stairwells are pressurized to prevent smoke from entering these areas. So, evacuation procedures in high-rise buildings also need to be planned carefully. Evacuating the entire building at the same time can cause, panic and control movement, and that's why staged evacuation is usually preferred. In this approach, the fire detection system first identifies the floor where the fire started and the affected areas also, and those areas are evacuated as a priority. The floors above and below are then informed and evacuated in a controlled way. Also, audible announcements and emergency guidance systems play a very important role in making this process clear and organized. Then the integration of fire detection systems with other building systems goes beyond evacuation and smoke control. In the event of a fire, elevator systems are automatically sent to a safe floor and taken out of service to prevent their use. Heating, ventilation, and air conditioning systems, which means HVAC, systems are either stopped or controlled based on the fire scenario to avoid spreading smoke and fire throughout the building. In addition, the fire detection systems support fire suppression by activating sprinklers, gas extinguishing systems, or other automatic extinguishing systems, helping to limit the spread of the fire. So, in conclusion, fire detection systems in high-rise buildings should not be seen as standalone or independent systems. They need to work together with building automation, smoke control, or evacuation announcement, and fire suppression systems as part of an integrated safety approach. When fire detection and perimeter systems are properly designed, compliant with standards, and regularly maintained, they become one of the most critical elements in protecting lives in high-rise buildings. So, thank you for your listening. Next week we'll be talking about detection in high-ceiling buildings. See you next Thursday at 11 a.m.